I'm very pleased to introduce Dr. Tara Javidi, who is a professor of electrical and computer engineering and is the Jersey George Lewak Chair in the Jacobs School of Engineering here at UC San Diego. Her work focuses on the theories of active learning, information theory with feedback, and stochastic control, as well as their application to the design of wireless networks and multi-agent robotic systems. Dr. Javidi is the co-principal investigator at the Institute for Learning-Enabled Optimization at Scale, TLOS, which is a very prestigious NSF-funded center, and founding co-director of the Center for Machine Intelligence Computing and Security. And she's the faculty director of the Eric and Wendy Schmidt AI in Science Postdoctoral Fellowship at UC San Diego. She's also the founder of Socher AI, a startup using active machine learning and sensing to ensure environmental monitoring of energy production and transportation facilities at scale. So just in our 4 presenters, you can see this cycle of producing knowledge, basic conceptual theory advancement into companies that are using these algorithms responsibly at scale. Today, Dr. Javidi will be presenting on data and information acquisition for AI-enabled scientific discovery, engineering optimization, and active monitoring at scale. Please welcome Dr. Javidi.
So thank you, Vice Chancellor Picasa. Thank you all for being here. So I'm going to talk about a little bit of half of the story of advancing AI on campus. I think Elise did a great job on the first half, so I'm going to talk about. So I'm going to just talk about pushing and developing new AI methods for doing engineering and scientific discovery, what I think of the second phase of AI. So the overall aim of all these programs that I'm involved is really to push what we have learned these AI and ML models are capable of, push their capability forward and try to repeat their success to help us build better engineering systems and speed up the scientific discoveries. So I'm going to just give you a flavor of the big picture projects that I'm involved with, the Schmidt AI in Science program, as well as the NSF AI Institute that VCR Picasa talked about, the TLOS. And then I'm going to focus in a little bit, talk about how that research gets to be sort of operational at the lower scale. So the Schmidt AI in Science program, just to give you a flavor, and this is a really good conversation for after the talk, the reception, and is a program that allows UCSD to train a new generation of scholars and researchers in the field with the mentorship from our faculty, some whom you have heard from, to really train scientists and engineers to use AI methods to do scientific discovery faster and at scale. So this program is in the 3rd year. We just welcomed our 3rd cohort, and it's a diverse set of scholars, some of whom are actually, Elise is one of the mentors of our new incoming. But just, this is just to show you that pushing AI into these fields happens at a massive scale on campus. There's no way I can talk about what these postdocs work. All I could do is just sit and listen. But if there's interest in learning about them, I'm a good person to sort of navigate those conversations to the next step. On the AI Institute, the NSF-funded research program, we basically are really looking at using AI for improving on the process of engineering systems that are becoming very large and very successful. And these are basically robotics, networks, and chip design. So we really look at foundational AI research that feeds into the use domains in the engineering space. And of course, we talk about translation and broader impact. And I want to sort of talk about, this is where I fit in. I'm really using the use domain of how these AI methods are using foundational methods can be used for developing better engineering solutions. I want to do a shout out. We have all talked about these multiple hats that we are wearing, but I just want to give you a sense. this is all the faculty and researchers involved with the AI Institute. The work I want to really first emphasize, the work is done under the leadership of Professor Yushu Wang at the Data Science Institute, who is leading the effort, but particularly other colleagues at UCSC who are working as the domain experts, as taking really what we know is successful in AI and really push the design of engineering system. For me, that has meant really thinking about if I want to use AI for designing the next generation of networks, wireless networks, how can we do this? And sort of we really look into optimization of these networks and how they can benefit. So this is the overall aim. In the next few minutes, I would like to kind of zoom in and focus a little bit about what does it mean when I say we're going to use these techniques to build better engineering systems. What do we exactly do? So I'm going to try to go a little bit in depth, and I'm going to talk about the challenges and opportunities associated with developing new AI methods for these new challenges. I think Elise did a really good job of saying there is a realistic physics-based methods that are really need to be incorporated with AI and ML techniques to be able to do scientific discovery. And I knew that she's going to go before me, so I knew that I don't, I can use that sort of extra time to really focus on the other two aspects that are really the shortcomings of previous models and what we are really engaged with when we do our work. So previous models, like when you think about pre-trained foundational models that, let's say, ChatGPT is built upon, they really do not account for the fact that the data in engineering systems, and especially in scientific discovery, is multi-resolution and adaptive. In other words, in all of the examples you saw, I can zoom in, right? You need a zoomability to be able to get what is at stake. You get the macro scale effect, but really you need to zoom in and really look deeper. And these models, these foundational models that we know how to train so far, they do not account for this. They're fixed resolution, you get the data and you build these models. So my research in my group has been how can we actually really build a new models that can allow adaptability or zoomability. And then this is really the other side of the coin for this is the data collection process. The first generation AI models take any data you have collected and try to build intelligence into decision making. But the data that has been collected could have been collected different ways. And so the second part of the story is really how can we actually use AI to optimize the data process and generate it for improving it. So let me go fast and just give you one example. This is the example that I'm working, and this is in collaboration and continuation of work that I'm doing with machine intelligence, computing, and security, and Soter AI. So really the idea is that our technologies, if you think about them, have grown way larger in scale than our ability to monitor them and know what is going on with them. Right? So in California, this has really meant that, basically our technology footprint has been really costly in terms of the impact on the environment, right? So what I'm showing here is the number of spills, accidental incidents on the planet. So this is, I want to emphasize, this is the incidents and accidents that were not planned for, right? This is not where we are doing our trade-off, whether going and utilizing these technologies is worth the impact on the Earth, which we have to do. That's the difficult conversation. These numbers of incidents are haphazardly happened because we didn't know what is going on with our technology, right? So this is my goal. My goal is really to reduce this cost. A student of mine is the person that I'm going to quote, was telling me that looking at these technologies that we have built is like being, watching a bull in a china shop. It's not a matter of when this giant creature is going to hit and create an accident. It's when, right? It's not if, it's when. You know it's going to happen. Why? Because just like this bull, our technologies are much larger than their abilities to sense,
monitor and really turn that into intelligent decision making, right? So the goal is to really address this, and this is what we are doing. And so I can give you the data in terms of how many, what is the cost. It happens in all industries, in energy production, in transportation, in space, exploration, and so on and so forth. And I would argue that the reason is that we have 3 requirements that are quite conflicting. We want the monitoring to happen fast. We want it to have a very large scale. We want it to be a large coverage, and we want it to be cost efficient so that you can build it together with the technology. And these are pretty hard to do. This is what when you look at what the monitoring systems do, they kind of trade off these 3 things. Sometimes they're fast, but they look at a really small area. Sometimes they look at a large area, but they takes a long time, and so on. Or sometimes they're very expensive. So the goal is to really push this, and this is what we are using the AI. So here is the new innovation. We now want to build a model, an AI model, that is allowing us to pay physical attention to this space. Right? What does that mean? That means that I need an AI-enabled operating system that controls what I have learned with what I'm actually able to collect more data about. So on the top level, that will really allows me to pay attention selectively to past experiences. If something went wrong 10 years ago, I would like to be able to go back and learn something from that and interact with that data. And on the lower level, I would like to use this AI engine to be able to manage and orchestrate my data collection process that happens. And this is where it's really exciting with the increased connectivity, robotics capability, and other technologies. This is really a matter of orchestrating this. And so to give you a sense, this is the kind of models we built. And now you can see that this is much more zoomable, right? You can actually get the details. You can ask for different kind of information. This is, for example, so we have a report due next week. So this is the sort of the report that we're planning to give to our industry partners. So, oops, sorry, I don't know why this does this twice. I guess all of that. This is just to appreciate the data collection process. And when you actually operate these systems, it allows the operator to really look into the data, ask questions, and really focus their data. So, okay, so I'm kind of like at the end. I hope that this new technology will allow us to pay physical attention to our planet. I'm hoping as the new generation of technologists, we're adding finesse to these old school technologies, get the most out of them in terms of their usability, but do it in a gentle way so we don't cause as many incidents. And I guess with that, I will stop. And thanks.